Hi teacher, I'm Maria Jose Gallegos and I'm from Team 9.
Hi teacher, my name is Juan Alfonso. I'm from Team 9.
Hi teacher, my name is Ana Daniela and I'm from Team 9. This is our exam.
The problem tells us, standing on a roof of a 30-meter tall building, you shoot an arrow straight upward. It takes 9.3 seconds to reach its maximum height. When going down, the arrow misses the roof and continues falling to the ground. The A tells us to find the arrow initial velocity. The B, the maximum height it reaches relative to the roof. The C, at what height relative to the roof will the arrow have a velocity of minus 45 meters per second? And the D, the time at which the arrow hits the ground. Well, in other words, basically the problem is a person who is in a building of 30 meters height and throws an arrow and it descends, so it's related to the theme free falling. If we put a Cartesian plane where the boy is, he is the point 0, 0, and his falling displacement is measured by the component y, which is equal to the angle which the arrow is going. As this is falling, it is negative. The constant acceleration of free falling bodies is called the acceleration due to gravity, and we denote its magnitude with the minus 9.8 meters per second, and will always be like that.
So here we have the shopping list. First, the problem gives us the initial position that is 0. Then, it's missing the final position. Next, we have the initial velocity that is missing 2. For the final velocity is 0 because the arrow reached the floor. The gravity is always gonna be minus 9.8 meters over second. And finally, for the time, the problem gives us that is 9.3 because at that time the arrow reached the maximum height.
How do we solve it? Problem 1, that is part A. They are asking us for the initial speed of the arrow. And to get it, we use the following formula. Initial speed is equal to final speed plus gravity per time. We already know from the information of the problem that the time is 9.3 seconds and the gravity is always minus 9.8. So we replace the values of the formula with the information we have, and the final result is 91.140 meters. Problem 2, which is part B. They are asking us for the maximum height it reaches relative to the roof. As we are talking about the component y, since it moves top from bottom, we are going to use it like that. To get the result, we use the formula y is equal to the starting position, which is 0, plus initial velocity in y per time, plus gravity per time squared over 2. We already have the initial velocity values in y, which is 90 and 1.140, and in time, which is 9.3, and the gravity will always be minus 9.8. As we substitute the values of the formula and the ones that we have, the final result is y is equal to 140.801 meters. In the exercise 3, which is C, they are asking us for the height relative to the roof with the arrow have a velocity of minus 45 meters per second. Especially for this exercise, I divide into two parts. The first part is to get the time that passes when the arrow is at that speed. Something that is important to know is that the velocity is negative since it's falling. As the topic that we are talking, free falling bodies. The formula we use in this time is time equals initial velocity at y minus initial velocity over gravity. The value we are going to use is minus 9.8, which is gravity, minus 45, which is the speed, in y, and the velocity that we get in the first problem, that is 91.140. The final result is a negative 13.890. To round it, we use two numbers, so it's 13.892. Now, the second part of the solution is the next one. We use the same formula as we did in the last exercise, and is equal to y is equal to first position plus initial velocity in y per t plus gravity per t squared over 2. We replace the values of initial velocity in y, which is minus 35, and the time that is 13.890 in the next numbers. We use all the multiplies because we want to have exact numbers. And the last final result for this part of the exercise is 85 meters. Yes. And the last exercise. This is part D. They are asking for the time at which the arrow will hit the ground. For this, we must follow 3 steps and the 3 formulas that go one from the other. We want the max range, but for this one we need the time max height. But for this one we need the initial speed in y negative. So the first step is to get that. I multiply the initial velocity in y plus the sine of the 270. Why 270? Because that is the direction of the arrow went. If we use a Cartesian plane, the going up is 90 degrees, going to left is 180 degrees, and going down is 270 degrees. The next slide, please. So we can see here the 3 steps we make. First of all, we need to get like the velocity in y, then the t max height, and then the t max range. For initial velocity in y, we get 91.140 plus the sin of 270, that the result is minus 91.14. Then, to get the t max height, we divide that result in minus 9.8, which is gravity. And then the result for this one is 9.46. Now we can get the t max range. We need to multiply t max height for plus 2, and we get 18.92 seconds.
So here is our final shopping list with all the values. Thank you.